this video, it deals with recursion. Hopefully in the most simplest way I can kind of display it while still being relevant to a practical situation, because this was actually a coding test that was given to me not so long ago. It's ripped straight off of Code Wars, and it wasn't the only part of the coding test. You still had to like kind of go through it and stuff and explain yourself, but um, it was kind of an interesting way. I looked online, not that you should ever look for a solution online for your coding test, but there was only one solution I could find on GitHub, which took a massively different approach. Maybe better, maybe not. But I chose to use a recursion approach, even though I had to do this test in Ruby, and there are some limitations to um, recursion in Ruby. However, in this case it worked fine. So let's start with a solution class, solution.rb. We're going to be doing this in Ruby. Again, you can translate this into any language, which is often a wise thing to do anyway, to translate stuff into other languages. So we'll need a class. We'll call it solution, and it needs an initialize method. Takes no arguments, and oops. What it does is it has a couple of links, and I will explain that as soon as we have this little map here. So this is the way we make a map in Ruby, but you might be used to calling that a dictionary or whatever. So let's write this out. We will have this. We will need this to make sense of the actual task in front of us. So that links to Bry, right? That's correct. So what we have here is the data that we were given for the test. So these define a couple of links between train stations. And I will now write down the task that I was given. So it'll be the solution spec. We will be doing this with tests. And so alright, so we have our spec here, or our description here, and it basically says like, okay, we want to go from an arbitrary station to an arbitrary other station. No matter how many other stations we have to visit in the meantime, is it possible to go from that station to that station? So for some stations that will be possible, and for some stations that will not be possible. Because if we look here, if we wanted to go, for instance, from ADL to Sydney, we can go through Mel. So because ADL goes to Mel, and Mel goes to Sydney, right? If we wanted to go from ADL to, for instance, Bree, we probably could do it. ADL to Mel, Mel to Sydney, Sydney to Bree. Yeah, so we can do that. If we wanted to go from Mel to ADL, Mel goes to ADL. Yes. Mel goes to Sydney. If we want to go from Sydney to ADL, we're kind of fucked, it seems, because we can only go to Bree. So, to actually make the spec, the tests work, we'll need to require our solution class, which we will implement later, because we will do this basically test driven. And we'll have an R spec, oops, to describe our solution. If it's possible, method if it's possible, do. So we have our RSpec block here. If we don't mess up too much, do and stay out of insert mode. Context. from ADL to Bry. Let's make a block. Okay, so it should return true. I don't know if in your job or whatever you do with code, you are exposed to a lot of like test-driven or testing, or in this case, we even have a subset going on called behavior-driven. But that might be a nice introduction for you as well, and I will explain this block as soon as I've typed it out. Solution, possible, ADL, dry, and we expect that to equal true. So, what have we done here? We've said, okay, describe me a specification around this class called solution, the one we have here on the right. That is our solution class. Let's actually also close that block there. We haven't implemented our solution yet. We don't have a method. We just have a constructor that gives us our data set that we are working with, which was provided by the people giving the interview, basically. So then we say like, okay, well, we'll define a context, which is basically like we're going to create a sort of a subset in our test suite that describes if we wanted to go from ADL to Bry. These are just the station names that we have in our data structure there. So then we say like, okay, we have a condition where the method that we're going to implement is going to be returning true. So we'll instantiate a new instance of our solution class, and then we say expect this method possible question mark with these parameters to equal true, to give back true. Now we haven't implemented this method yet, but we will do that now. So we'll go back to our solution class and we'll implement the possible method. That will have a start, a target, and a visited array. So at this point we have the beginning of our method. Well, we might as well try to write this out. So we have our three inputs here. Start and target is obviously what we defined here, possible from ADL to Bry. So our start is ADL and our target is Bry over here. We know that we can make that. That's why we expect our solution to equal true. So this method is going to return either true or false, or does something kind of strange, which is called recursion. So first we will want to get the branches of our current start. So what that means basically is what we are selecting here is everything in this array, because our start is ADL, and if we go into links and get the key ADL, we get Mel as our branches, because this is an array of strings. And here, if we selected Mel as our start, we would get ADL and Sid as our branches. So this is now, at this point, defined like this. Up. That's what we have in branches right now. So we will return false if branches nil. So this is kind of called a guard. This just says like, hey, if we don't have any branches, we obviously cannot travel any further. So therefore, we cannot return true, because there is no destination for us. There's no target for us to go to. Now, next thing we do is we create some memorization, some memory. So we say visited, which is now an empty array. Let me add start to that. So that means like we visited the station start. So we wanna ignore that later, so we don't get like weird infinite loops. So we say like to this empty array of visited, add our start ADL to that. So then we will return true if branches include the target. So what this says is like branches is now an array of possible targets to go to next. Now if that includes that array, if that has the target already in there, we know that we can make it there. So we have no more work to do. We can return true. We found our target. However, if not, we need to go and loop over our branches. No matter if we only have one or many, we just need to loop over that array of branches that we've created. Yep. And what we will do now is say like, okay, well, if we haven't visited the current branch, then we will say the result equals possible, and this is where it's happening, branch target visited. So this is where the recursion is happening. Now what we will need to do is one more guard. If result class is not an array, then return result. So basically what this does right here, this is the key line right here. What that does is it says the result is call this function again. However, now instead of passing in the original ADL as the start, put that branch in there. So that branch currently is mel, right? Because we started with ADL, our branches is mel. So we are looping over that. So branch is currently mel, and we say like, okay, return possible with branch the original target and whatever we've already added to visit it. So what we can do now is like, now what it will do is it will call this method again. However, now it will start over here, and then it will say like, well, ADL, I visited that, so I'm going to ignore that, right? The next loop I will do right here in branches, we are now, is Sydney. Okay, cool. We found Sydney. So that means we've found ourselves a there's something wrong over here, or isn't there? No, it's just the coloring, is it? Anyways, yeah. So at this point, like, we are saying like, okay, well, what we have found is not an array, so there is no more. We've actually landed on an end station, right? So right here, when we've called this a couple of times and we've basically walked what is basically a tree, then we found the Bry station that we were looking for, and then it will return the result, meaning this is either true or false, because possible will always return true or false. So it will either return true or false or call itself again. That's basically how you should see that, and that is recursion. At that point, let's just finish the test suite. What we can do is create a few more tests. So from mel to, did I say Bry? Yeah, Bry, do, and it should return true again. Solution is solution.new, and expect solution possible. What did I say? Mel to Bry. Expect that to equal true. And then also try to, when you're testing, make sure that you are also testing things that aren't possible. Oops. So it should return false. Solution is solution.new expect solution.pop possible sit ADL to equal false. Now, I'm not 100% sure if this will work, because I'm not sure if I'm set up actually for for testing at the moment. Like I said in other videos, I haven't programmed Ruby in a while, so yeah, I figured as much. Let's see if we can set this up. Does it want me to give them the file? Yes. Undefined visited. Okay, so we have some errors. If visited 17, it doesn't like 17. Visited. Alright, it still isn't kind of happy. Let me just do that again so I can see why. Include, okay. This needs to be with a question mark. I mean, this is just syntactical stuff. To equals, undefined method to equal. Did you mean to s? That's interesting. Why would that not work? Oh, okay. Now, that's probably, it looks a bit weird in Ruby, most likely. Here we have 3 examples, 0 failures. So again, our tests run, they go through the code, and they show us like indeed we get back what we expect. Now, to explain maybe some of the weirder things of Ruby, it doesn't really care whether or not you use brackets or not. So this is basically saying the same as that. If I recall correctly, this should work. Yeah. So in Ruby, just for syntactical sugar, you can omit that kind of stuff. Yeah, it looks nice, I guess. So in another scenario, I just wanted to explain this recursion and the uses in one more additional way, I think. Let's say that we have a database connector, right? Like something like this. And we're gonna just sort of pseudo this because we don't actually want to like go through the trouble of making a database connector. But let's say we have a database class, something like that, and then what it will have is something like a connect function, right? So in the connect function, we'll say, well, let's say that all it knows is basically that it has tries, and maybe it'll default to 3 or something, right? So it will try 3 times to connect to the database with some sort of a backoff or something. So the way that we would call that is say like db is equals db dot new, and then you would give it, you know, its connection string and whatever, and then we just say db dot connect, right? And we can then also say like, well, we want to try 13 times, but for now let's stick with the default. So 3, what this will do is like, well, it will call your whatever your client object is, and then sort of call connect on that, and then maybe like maybe this will return like an error or something, and then you just say like, well, if the error is not nil, I'm kind of like doing a little bit weirdly a mix of Go and Ruby at the moment, but the concept is the same. So like you say, if the error is not nil, call connect again. So that's the recursion, right? However, this time you just call tries minus 1, right? So now it calls connect with tries 3. What you can do here is just put another guard. Like you say like, well, you could do various things. You could return if tries equals 0. It's a good guard. More likely you would like to do something like maybe if tries equals 0, do something like, well, panic or something, you know? So like basically raise could not connect to the database after, I don't know, 3 tries. So you see how this, like, instead of like having to write a lot of logic, a lot of if statements, like if try is bigger than this, then and then, you know, go to a try again method, or like splitting it out into connect and actual sub methods, so you could call those individually without duplicating yourself too much. Here, all you have to do is just call yourself a couple of times until, you know, it either works or it doesn't. So and then if it does work, then you just I don't know, like you return something. You can return true, or you can return your database object or whatever, like. So that is really like one of the better uses of recursion. It can keep code clean, and in some cases, like, you don't even really have a choice. Like if you look at Erlang, you don't have loops, so like you only have recursion, and recursion is like looping. You know, it is the fundamental means of making a loop.